Hello everybody, welcome back to another video. Today we're going to be solving a really interesting problem. Let's get right into it. So we have the derivative of x tetration infinity. At first this can seem like a very daunting problem because we have the infinity symbol, we're taking the derivative, and there's so much going on here, but let's break it down. Alright, if you're a calc student, you might be confused on what this infinity symbol or positioning really means, but it's quite simple. This is just tetration. So if I have the number 3 to the power of 2, this is just equal to 3 times 3. And I explained this in my other videos as well, so check those out. But if I have 3 tetration 2, this is equal to 3 to the third power. And similarly, if I have 3 tetration 4, this is just 3 to the 3 to the 3 to the 3. And something to note here is when I'm doing tetration, I don't work from the bottom up. I instead work from the top down. So I'm going to do 3 to the power of 3 and raise this like this. So it's essentially this order of operations. And I have 1, 2, 4 threes here. And that's where that 4 comes to play. Just like I have my 3 squared, 3 times 3. So with this understanding of tetration, we can now solve this problem, actually. That's all you need. So for the sake of this argument, or for the sake of this video, I'm going to be setting y equal to this inner function, x tetration infinity. So let's say that y is equal to x tetration infinity. I'll actually do the infinity in red because it looks cooler. And if you want to represent this conceptually, you can think of it like this, x to the x to the x to the x infinitely. And we're going to be starting there and working the way down. But that's how the order of operations works. So with this new knowledge, what we could do is say what we're trying to solve for. The derivative of x tetration infinity is going to equal the derivative ddx of y, which is just equaling y prime. So what this means is we can do something quite interesting. If you've seen my previous videos, you'll notice something. I'm going to write this 2 times, and you'll hopefully see what I'm about to do. You'll notice our definition of y was y is equal to x to the x to the x to the x infinitely, and y is also this. It's the same thing twice. But I wrote this in red intentionally because we can substitute this x to the x to the x for another y, essentially saying that y is equal to x to the y. And we can verify this by saying this. This is equal to x to the y, but what is y? Y, per definition, is x to the y. So this would be x to the y. But what's y? Y is x to the y, so it's x to the y. But what's y? X to the y, so on, so on forth. You can continue this and you get your infinite chain. So this is indeed true. We can get y is equal to x to the y. Now, what are we trying to find? We're trying to find y prime. I'll write a question mark here. So to find y prime, we can simply use implicit differentiation to continue from here. Using implicit differentiation, we can get ddx. On the left-hand side here, we're going to have, oh, but by the way, before I do ddx, because I have y in the exponent right here, I actually would want to take the natural log. So by taking the natural log, I get natural log of y equals y natural log of x. Because when taking natural log, you can bring the exponent down as a coefficient of the ln of x. So this makes it easier to implicitly differentiate because it's hard to differentiate a function in the exponent like that. You can check out my video on x to the x to see another example of where I do that, but yeah. So now we can differentiate on both sides, and by doing so, I'll simply move this here. We'll use green now. ddx of ln of y is equal to ddx of y ln of x. So we can simply differentiate using implicit differentiation. We have 1 over y times y prime, according to the chain rule, is equal to, we have product rule here, ddx of fg is equal to f prime g plus g prime f. So we have the derivative of y, which is going to equal y prime. We leave the other part alone, and then we add, we leave y alone this time, y, and then what's the derivative of ln of x? 1 over x. So we just have to solve for y prime here. What we do now, we subtract this on both sides, and then we can solve for y prime and factor out. So we have 1 over y times y prime is equal to, minus ln of x. Ooh, that's a weird ln. Minus ln of x, y prime, is equal to y over x, just like that. Now, we can factor out the ln of y. We're going to get y prime times 1 over y minus ln of x is equal to y over x, just like that. Now, we can divide on both sides to get our answer. Y prime is equal to y over x times 1 over y minus ln of x, just like that. Which is a pretty cool answer, if I'm going to be honest. But to simplify this a little bit further, I'll write in red. Y prime, we're just going to multiply by y over y because I don't really like that y in the denominator there. But by doing so, we get y prime is equal to y squared at the top, which is, we'll get to that in a minute, times x, and then by essentially multiplying by y, we can distribute this. This becomes 1, and this becomes y ln of x. So we get x times 1 minus y ln of x, just like that. Now, this is our final answer, and it was a really cool problem. But to look cooler, we can really plug in y for what it was originally. Y is x to the x indefinitely. So, ladies and gentlemen, that means our answer, I'll do it in red again. Our answer for today is y prime is equal to x to the x to the x to the x dot 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 all squared all over x times 1 minus x to the x to the x dot 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 ln of x. Now you'll notice something right here. You can even simplify this further, but this is just to look cooler and be more fun. But this x to the x to the x to dot 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 can actually be placed inside of the ln of x, because when doing so, it's essentially the same thing, because x to the x to the x, if you just add another x to the base of it, it's equal to itself. So if you didn't catch that, you can replace this with x to the infinity, x tetration infinity. But when you put this in the ln of x, it's still ln of x tetration infinity. So if you want to look even cooler, your final answer is going to be y prime is equal to x to the x to the x dot 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 all squared, which I have no idea what that even means, to be honest, times all over x times 1 minus ln of x tetration infinity. Hope you guys enjoyed today's video. Let me know if I made any mistakes, if I didn't explain something too clearly, or if I went too fast. Give me some future video ideas. Please drop a like, follow, share the video. Thank you guys so much. Have a great day.